everyone. My name is Harnit Saini. I'm assistant professor in AKGEC Engineering College. Today the topic of discussion is bipartite graphs. Let's start. First, we should know what is a bipartite graph. A bipartite graph is a graph in which the vertex set can be partitioned into two sets such that edges only go between the sets, not within them. A graph GVE means V is a set of vertices and E is a set of edges. Is called bipartite graph. Its vertex set VG can be decomposed into two non-empty disjoint subsets V1 and V2 in such a way that each edge E belonging to the edge set has its one last joint in V1 and the other point in V2. The partition V is equal to V1 union V2 is known as bipartition of G. Now, what the definition says, if there is some graph, right, it has four vertices, right? One by one, we have to check all the edges and we have to make the partition of vertices in such a manner that for every edge, one vertex is in one set and the other vertex is in other set, right? If we are able to do this, that means that is a bipartite graph. Now see here, if we see this A, B, A is we put in V1 and B we put in V2, right? Now we check this edge, right? A is in this set, then D should be in this set, right? Now we check this edge. If D is in this set, then C should be in this set, right? Now we check this edge. B is here, then C should be here. It's already there, right? That means for all the edges, one vertex is in this set and the other vertex is in this set. So this is a bipartite graph, right? Now let's check whether this graph is a bipartite graph or not, right? We have vertices x1, y2, x3, y1, x2, y3 and x4, right? First of all, we have to make the partition of the vertices V1 and V2, right? First of all, we will test for this edge. One vertex is x1, we will keep in this. Other vertex is y2, we will keep in this, right? One edge is complete. Now let's take this edge. x1 is in this set, then another vertex y1 should be in this vertex, right? Come to this edge now, right? Y1 is in this set, then x2 should be in this set, right? This edge is complete. Come for this one. X2 is in this and y2 should be here. It's already there. So no need to write again. So all these four edges are complete. Now let's go for this edge. Y2 is in this vertex, then x3 should be in this set, right? Now for this edge, x3 is in this set, then y3 should be in this set, right? This edge, x2 is in this, then y3 should be here. It's already there. No need to write again. Then this edge, y3 is here, then x4 should be here. Now for every edge, we are able to partition the vertices, right? That means it is a bipartite graph. Now, if we want to draw the same graph in this manner, set of vertices we keep at one side, right? x1, x2, x3, x4, x1, x2, x3, x4, right? And y1, y2, y3 at one side, y1, y2, y3 at one side, right? Now here we can see that x1 and y2 there is an edge, x1 and y2 we make an edge, right? x1 and y1 there is an edge, x1 and y1 we made an edge, right? Similarly, y1 and x2, y1 and x2, x2, y2, x2, y2, y2, x3, y2, x3, x3, y3, x3, y3, x2, y3, x2, y3, x3, y3, x4, y3, x4, right? Now, this graph and this graph are same graphs, right? Because the number of vertices are same, number of edges are same, and their connections are also same. So we can draw the bipartite graph in both ways, right? Now let's check the another example. We have two graphs again. We have to check this whether it is a bipartite graph or not. Let's make the partition again, V1 and V2, right? First, we will start from, you can start randomly from any vertex. It's not compulsory that you have to start from here only, but you have to cover all the edges and all the vertices, right? Now let's start with x1. This edge, if x1 is here, then y1 should be here. This one, x1 is here, y2 should be here. x1 is here, y4 should be here, right? Now these three edges are covered. Then we come to y4. y4, this edge is covered, this. y4 is here, then x3 should be here. y4 is here, then x4 should be here, right? We have covered this edge and this edge, right? Let's come to this vertex now. x4 is in this one, then this we have covered. y3 should be here. y1 is already there, no need to write. What all edges are left? We are left with these edges. y2, x2, y2, x2, right? y2, x3, y2, x3, x3, y3, x3, y3, x2 and y3, right? And this about this edge is left now, x2 and y1, right? Again, we are able to make the partition here. This is a bipartite graph now. Again, we can draw this graph in such a manner. We will keep all these vertices at one side here, these vertices at the other side here, and we can make the same edges, same connections which are in this graph. We can make the same connections in this graph, and both the graphs are same, right? Now let's check this graph now, right? I have colored these graphs, colored the vertices so that you can make it out that one blue is one set and red one is the one set. Now let's check this graph, right? Make the partition V1, V2, right? Now we come to B, blue B, then 3 should be red, right? Then A should be here, and if we check about this edge, 3 is here, okay. This edge, A is here, then 1 should be here, okay. These are all red ones, these are blue ones, right? Then this edge, 1 is here, then E should be here, right? This edge, E is here, then 4 should be here. This edge, E is here, then 5 should be here. This edge, 4 is here, then C should be here. Then this edge, C is here, then 2 should be here, right? We have covered all the edges and the vertices. Now you see A, B, C and E. They are all blue in color, right? And 3, 1, 4, 5, 2, these are all in red color, right? This shows that this graph can be a bipartite graph. Now again, we can draw this graph in this manner also. Keep the red vertices at one side, blue vertices at one side, and draw the edges the same way they are drawn in this graph. Like, there should be an edge between B and 3, B and 3, there is an edge. 3 and A, 3 and A and 1, A and 1, 1 and E, 1 and E, right? Then E to 4, E to 4, E to 5, E to 5, 4 to C, 4 to C, C to 2, C to 2, right? All the edges in this graph are same as in this graph. So these both graphs are same. We can draw this graph in this way also. Both are bipartite graphs. Now see this graph. This graph is not a bipartite graph. How? Let's check. This is 1, this is 2, this is 3, let's 4, 5, 6, 7 and 8. We have numbered the vertices. Now we have to make the partition of the vertices. V1, V2, right? Now let's start with this one vertex. If, let's take this edge, right? If 1 is we keep in this set, then 2 should be in this set, right? Let's take this edge. 1 is in this, then 3 should be in this, right? 2 is in this, then 4 should be here. 4 is in this, then 5 should be here. 4 is in this, then 7 should be here. 5 is in this, and 6 should be here. 6 is here, then 7 is here, it's okay. 5 is in here, then 8 should be here. 8 is here, then 7 should be here, okay. Now we are left with this edge, right? 2 is in this here, then 3 should be here, but 3 is in this set only, according to the partition of the whole graph. If for this edge, 2 is in this set, 3 should be in this set, but it is not there. So that's why this is not a bipartite graph. Okay. Again, one more example. 1, 2, 3, 4, 5 and 6. Right? Again, you see this. V1, V2. Start from here. 1. If we keep 1 here, then 3 should be here. 1 here, then 2 should be here. Right? 3 is here, then 4 should be here. 4 is here, then 5 should be here. 5 is here, then 6 should be here. 6 is here, then 4 should be here, but it is not there for this edge. Similarly, for this edge, 2 is here, then 3 should be here, but it is not there, right? So this is also not a bipartite graph, right? Thank you very much.